quadratics, you're going to have a trinomial of the form ax squared plus bx plus c, or a binomial, which is ax squared, or a squared x squared minus b squared. Okay, and this is a difference of squares. Okay, now when we're factoring a trinomial, we want to look for two, well, there's a couple of ways that you can do it. You can use guess and check, trial and error. Trial and error. You can look for two numbers that multiply to a times c and add to b. Okay, if you want to do it more systematically. And I'm assuming you guys have a lot of practice with this kind of stuff at this point. Okay, with a difference of squares, right, this guy's going to factor into ax plus b times ax minus b. Okay, so something like this, don't forget to check for GCF first. Okay, something like this guy, right? Is there a GCF there? Yep, GCF of 2, so we can take that out. We're left with x squared plus 7x plus 12. Okay, now this is a trinomial where actually the coefficient of the x squared term is 1. And that kind of cuts the process down a little bit, because now when you're looking for two things that multiply to a times c, well, since a is 1, you're just looking for two things that multiply to c, right? So what multiplies to 12 and adds to 7? 3 and 4, yeah. And so when that's the case, when the a value is 1, you can just plunk those two values in there. Okay. In this scenario, 10x squared minus x minus 3, okay, is there a GCF there? No. Okay, so here we can do one of two things. We can use trial and error, or we can find two things that multiply to a times c and add to b. Which way do you guys want to do it? Or do you want to do it both ways? How many people do it systematically where you find two things that multiply to a times c and add to b? Okay, let's do it that way, because if you use trial and error, then you're probably pretty good at that, right? Okay. So if we're trying to find those two numbers that multiply to a times c, here we're looking for two things that multiply to 10 times negative 3 is negative 30. What do they have to add to? Negative 1. Okay, what are they? There you go, negative 6 and 5. Okay, once you have those two numbers, now I've seen people either use decomposition or the box method. Which way do you guys usually do it? Or sometimes people do half and half. Do you usually do it all on one line? Yeah? Okay. So when you do it all on one line, what does that line look like? 10x squared minus 6x plus 5x minus 3. Yeah? Yeah? So this is called decomposition. Have you heard that term before? Because you're decomposing this middle term, negative x, into two terms. Okay? Okay, now what? Yeah, so we group these two together, and we group these two together, right? And then you factor a GCF out of each of those. So in the first two terms, there's a GCF of 2x. And we're left with 5x minus 3. And is there a GCF in the second two terms? So what would you factor out if there's no GCF? Just 1, correct. Okay, and now we have a common factor binomial, right? This is now a common factor. So we can pull that out in front. And what's left over is the 2x plus 1. Okay? All right. This guy, 18x squared minus 8. Is there a greatest common factor there? Yes. What is it? 2. And we're left with 9x squared minus 4. Okay, so now what do we do? Difference of squares, right. So we get 3x plus 2, 3x minus 2. Okay? Questions with that so far? All right. Let's move on to cubes. Okay, so I've got some general rules down here. Have you guys seen these before? A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Or a squared, or a cubed plus b squared, b cubed, what am I saying? Equals a plus b times a squared minus ab plus b squared. Have you guys seen that before? Okay, so this can be handy because this type of factoring comes up quite a bit. But you don't need to memorize it because you can do polynomial long division, you can do synthetic division, okay? So it doesn't like come out of nowhere. So let's say, for example, we wanted to factor this one, right? So if you're looking at what could be the possible factors, you're going to look at the coefficient of x cubed and this constant term at the end to try and figure out, well, what could I try, right? So some of the things you could try are 2, -2, 1, 8, 4. Those are all things that you could try. Okay? So just to kind of speed things up a bit, based on this pattern over here, what should be a factor is x minus 2. Okay? So let's just review synthetic division. How many people remember synthetic division? So, okay. To show that this actually does in fact factor the way that this sort of rule says that it should. Okay, so when you're doing synthetic division, you want to make sure that you're not missing any of the coefficients in this polynomial, right? So we're missing a couple of terms here. So I'm going to rewrite this as x cubed plus 0x squared plus 0x minus 8. Yeah? Okay, and then with synthetic division, I'm going to make this sort of upside down division line. And if I think that x minus 2 is a factor, I'm going to put a positive 2 over here. And then in here, I'm going to put all of these coefficients. Or in the case of the -8, it's a constant. Okay, so 1, 0, 0, -8. And this first guy, I'm just going to bring down. And then I'm going to go 1 times 2 is 2. 2 plus 0 is 2. Two times 2 is 4. So that's a 4. And 0 plus 4 is 4. And 4 times 2 is 8. -8 plus 8, 0. So if you get a 0 here, what does that mean? That this is a factor, that x minus 2 is a factor. Okay? Now the reason why synthetic division is nice is because these numbers give you the coefficient of what's left over.
Why is it x minus 2 if it's just put in 2?
What's that? Well, that's kind of what I tried,
Yeah.
right?
How come that's...
That's going to be a factor because the remainder was 0. So what this becomes is, well, that's an x minus 2. What's left over is, this is the coefficient of x squared, so 1x squared plus 2x plus 4. Okay, and this follows that same pattern, right? I've got a, if this is my a, x cubed is my a, and b cubed is my, b cubed, the b here would be 2, because 2 cubed is 8. Right? I have a minus b, x minus 2, times a squared, x squared, plus ab, 2 times x, plus b squared. B squared is 4. Yeah?
Isn't there a way to check if, like, 2 is a factor?
Yep, you can use the remainder theorem.
Yeah. What's that again?
The remainder theorem?
Yeah, but, like, how do you do it?
So what you would do is you would plug in a 2 into, you would plug in a 2 for x. Okay, and if you get 0, then it's a factor. Now, that's a good way to start to check, but the only thing that it doesn't do is it doesn't give you this, right? So the benefit of doing synthetic division over the remainder theorem is that you don't have the polynomial that's left over, right? So if you want to know what does it factor to, you would know that x minus 2 is a factor, but then you don't know x minus 2 times what, right? Yeah. Now, what you might find, though, is throughout this course, this type of polynomial, either a cubed minus b cubed or a cubed plus b cubed, comes up a lot. Okay? And so you may have to start out doing some synthetic division after a while, or at the beginning. And then what you'll find is, oh, after I do this for a little bit, I'm starting to notice that this is what transpires, right? It's the same pattern over and over and over and over again. And so now I don't really have to go through the process of synthetic division because I know what's going to happen. Does that make sense? Okay. Okay. Okay, now, this, I'm not sure if you guys have seen this before. Have you seen factoring with rational exponents? Okay. So this we sometimes have to do as well. And if you haven't seen it before, it's kind of like, what? What do I do here? Okay, and I'll give you a hint. The hint try and factor something out so that the initial term is x squared. That's usually a good way to go. Okay, so I actually can't, my smartboard is so bad. You guys can see in your notes. I can't even see what that is. It's x to the 3 over 2, right? So what I want to do is I want to factor something out so that I'm factoring something out times x squared, because eventually I'm going to multiply those two together, and I want to end up with x to the 3 over 2. Okay, because let's say you factor something out, right? If I have something like 2x squared plus 5x, right? Let's take something really simple. I factor out an x, and I get 2x plus 5. Well, what I factored out, when I take this and I multiply it by that, I end up with x squared. Okay, so I don't know. Firstly, I know I'm going to factor out a 2 because there's a GCF amongst the numerical coefficients of 2. I don't know what the exponent is on that. So I'm just going to call it a for now. I don't know what it is yet. Let's call this x squared because I want that to be x squared. That's my goal. Now, if I multiplied those together, x to the a times x squared, I want to get 3 over 2. Okay, so let's just do that over here. Off to the side. Okay, now here's where we use all of our math all at the same time. Okay, now we're going to use our exponent laws. Okay, when we multiply two powers with the same base, what do we do with these two things? Add. Okay, so what we can take from this is a plus 2 equals 3 over 2. So what plus 2 is 3 over 2? You may actually want to do, this would be, or you could actually do it this way. You could create a common denominator here, right? So this is over 2. 2 is how much over 2? 4 over 2. So you may do it this way as well.
Please excuse this interruption. This is an all call for any student at all who has not picked up textbooks. Please go to the textbook room and pick up your books. Thank you.
Okay. Now how do you solve for a? Yep. Yeah. So, right? So 3 over 2 minus 4 over 2 is negative 1/2. Yep, go. Okay. So this, I'm just going to erase this and erase that. Has to be negative 1/2. That's what I have to factor out to make this x squared. Does that make sense? Okay. Now, this next term, so firstly, 2 times 10 is 20, right? And this is 1/2. Okay, so you may have, it takes a little bit of time to get the hang of this, but once you do it a few times, it's like, oh yeah, okay, I know what I'm doing now, right? So you want to do like, if you want to know what's left over here, right? X to the negative 1/2 times x to the a equals x to the 1/2. Right? That's what's going to be left here. Because again, you're multiplying this times this, and you're left with that. You're imagining that you're expanding back in, and what you want is x to the 1/2 as you're factoring out. Does that make sense? Sort of, yes, no? How many people it doesn't make sense? Don't be shy. No? Okay. Well, if we do the same sort of thing here, this is going to be negative 1/2 plus a equals 1/2. Okay, so to solve for a, we just need to add a 1/2 to both sides. Okay, that one, a 1/2 plus a 1/2 is 1. So the exponent on x there is just 1. And if you think about it, x to the negative 1/2 times x to the 1. If you add negative 1/2 plus 1, you get 1/2. Does that make sense? Yeah? Okay. Now the nice one is the last one because this is x to the negative 1/2. So if you factor that out, right, and you factor out 2 as well, all you're left with is 21. Yes?
So I have a question. So if it always turns into a quadratic function, can you just look at the exponent on the last term and then
Yeah.
that's your...
That's typically what happens as well. Yeah. So I was going to get there. Yeah. You can often just, not always, but you can often just look at what's the exponent on the last term as well and factor that out. Okay? And actually, we will take that shortcut in the next one. Okay? So now you can factor what's left, right? And here we're looking for two things that multiply to 21 and add to 10. What are those? 3 and 7, yeah. Oh, sorry, this should be negative. Okay, so this looks like it's something that's completely not factorable, and yet now we've been able to factor it. Okay? All right. What you might actually do as well, I'll bring this up as well, we may actually not leave it in this form because this is a negative exponent, right? So typically what we do at this stage is we'd write it this way. And instead of writing it as x to the 1/2 in the denominator, we'd write it as in radical form. Well, we could write it either way, right? I'll do it that way so that you guys can see it both ways. Okay? Right? Because x to the 1/2 is the square root of x. So we'll leave it like that just so that you can see both. Okay? All right, so let's, for this guy, actually do that shortcut. So let's say we wanted this last term to just be a constant, right? Well, then we have to factor out this. And in this case, this is x to the negative 1/3. And that often is what you have to factor out, right? So if you're not sure where to start, that's often a good place to start, okay? So, and also, of course, look at the coefficients and see if there's a GCF there, okay? So here we have a GCF of 3. Say that again?
How come A equals 1 but also equals negative 1/2?
A equals 1?
Yeah, just at the very bottom.
Over here?
No, at the very bottom of what you...
Oh, I'm sorry. You know what? I should have used a different variable here because I was solving two different problems. For the first one, I was doing this first term, and the second one, I was doing the second term. So this should, let's call this B.
Okay.
Yeah. Sorry.
Okay.
That is confusing. Yeah. Okay. All right, so for this last one over here, let's try this where we take out the x to the negative 1/3. And we'll also take out a 3 because there's a GCF of 3. And also, by the way, what should we do if the first term is negative? Take the negative sign out as well. So we'll take a negative 3x to the negative 1/3. Okay. So negative 3 times 2 is negative 6, so that's an easy step. Okay. Now, in terms of the exponent, we're probably pretty sure that it's going to be an x squared. But what you want to check is this. Remember, the exponent here plus the exponent here has to equal 5/3. So does 2 plus negative 1/3 equal 5/3? Is that true? How many thirds is 2/3? What would this be over 3? 6 over 3. So 6 over 3 plus negative 1 over 3 is how many over 3? 5 over 3. Yeah, so this does work. Make sense? Okay. And then here, negative 3 times 1 is negative 3, so plus 1. And of course, you can leave the 1 out. We're pretty sure this is going to be an x, but again, you want to make sure negative 1/3 plus 1 should equal 2/3. Is that true? Right? Because if this is a 1, we need these two exponents, negative 1/3 plus 1, to equal the original one if we're expanding back in. Because when we factor out, we want to end up with what we started with. Okay, is this true? Negative 1/3 plus, this is 5 over 3. Is negative 1/3 plus 1, is that 2/3? Yeah. Okay, and then of course this one, when you factor out negative 1/3, you're just left with a number, so plus 1. Okay, can this factor further? 2x squared plus 1x plus 1? Yes. Oh, this should be minus. You're right, that's a plus. Thank you. Yeah. Now it factors, yeah. Good, yeah. Yep, now it can factor. I was actually looking at that and I was like, no, it can't factor. But now, yeah. And my smartboard is really terrible. Actually, does this help? Is that better? Okay, we'll do that. Okay, even still, it's a bit fuzzy. Okay. Yeah, so now this can factor further. So we're going to end up, I'll just move over here, negative 3 to the x to the negative 1/3. And here, you may have to take some extra steps. But you know what? Let's do, I know that you guys said you don't like to do this, but I'm going to do guess and check. Because this is a pretty simple one. Okay? Now, what I mean by guess and check is this. The first two terms need to multiply to 2x squared. There's only two things that can multiply to 2x squared. 2x and x. So that has to be a 2x and an x. Right? There's only two things that can multiply to negative 1. 1 and negative 1. So these both have to be a 1. The only thing that we need to play around with here is which one is negative and which one's positive, right? So what I'm going to do is I'm going to say, okay, let's suppose this one's negative and this one's positive. What would happen? Okay, if this one's negative, I know that that's 2x squared, I know that that's negative 1. So that's taken care of. Okay, this would be 2x minus x. 2x minus x, that's positive 1x. That doesn't work. So I don't want to do that. So I'm going to switch it. Plus, minus. Okay, now I'm going to have negative 2x plus x. Negative 2x plus x is negative x. Does that make sense? Yeah? Okay. So for simple ones, if you do factoring enough, guess and test can be a really fast process, or trial and error. Okay? And personally, what I do is I do a mix of everything, right? I look at something and I'm like, what's going to be most efficient? If I'm solving an equation, I will sometimes use the quadratic formula, even if it's factorable, because it's faster for me. Yeah?
Wouldn't it be the other way around since the middle term has to be positive?
Yes. The middle term has to be positive. Thank you. Oh my goodness, I'm off my game today. You're right. Okay. So what was that? This was a positive, negative. Ugh. All right. Negative, positive, right? Oh, brother. Plus 2x minus x. There we go. Okay. You know, they say like the best mathematicians are terrible at arithmetic. Albert Einstein, terrible at arithmetic. Not that I'm saying I'm like an amazing mathematician or anything, but anyway. Let's move on to rationalizing. Okay, so rationalizing denominators. In like grade 11, we told you make the denominators rational. We don't like irrational denominators, right? Okay, so in calculus, we throw that all out the window. Sometimes it's useful to rationalize the denominator, and sometimes it's useful to rationalize the numerator. It really depends on the question. Okay, but in either way, we have to learn how to rationalize. Okay, now rationalizing, basically, we're taking like an a minus b, right? It's almost like doing a difference of squares with whole numbers, right? So a times square root of a times the square root of a is a, right? And then this would be the square root of a times the square root of b. So if we were to expand this out, this would be plus the square root of ab, and then minus the same thing. And then minus the square root of b times the square root of b is minus b. So this just becomes a minus b. Okay? And this is called, these two things, do you remember what they're called? The relationship between these two factors? Not reciprocal, it starts with a C. Conjugate. Yeah? Okay, so rationalize this. Well, if we wanted to rationalize this denominator, if we wanted this to be rational, we'd have to multiply this by its conjugate. Okay? The only way to do that and keep the expression the same is if we multiply the numerator by its conjugate as well. Okay, so that's what we're going to do. We're going to multiply by the conjugate over the conjugate. The conjugate of this is the square root of x plus 9 plus 2. Plus 2. Okay? And when you see anything in calculus where you have something like this, where there's a square root plus something or a square root minus something, and you're not sure what to do, try multiplying by the conjugate over the conjugate. It's a really good step to take. Okay? All right, let's just practice doing it though. So, in the numerator, there's really nothing to do at this stage. Okay? So we're just going to leave it as is. X squared minus 25 times the square root of x plus 9 plus 2. In the denominator, though, well, the square root of x plus 9 times the square root of x plus 9 is just x plus 9. Right? And then we're going to get negative 2 times positive 2 is minus 4. Okay? And because this almost takes the format of a difference of squares, we know those middle two terms are going to cancel out. So we're not going to worry about them. Okay? Now, if we take a look at what's going to happen here, x plus 9 minus 4, that's going to become an x plus 5. Yes? Now, I can see here, this is an x squared minus 25. If I factor that, there's going to be a common factor there. Okay? So I'm going to take care of that as well. This is a difference of squares. So this is x plus 5 times x minus 5. This stays as is, square root of x plus 9 plus 2 over x plus 5. Okay, and then these cancel.
Can we make it
A plus 2?
Yeah.
Because that was the conjugate.
Okay.
Right? So in the numerator, nothing is going to simplify there or cancel. Does that make sense?
Yes.
Okay. And when we expanded here, it became a minus 4. Because plus 2 minus 2 becomes negative 4. Okay, so this is our, I'm not going to write it out again because I'm running out of space. But that would be simplified. Okay. Last one. Rationalize the numerator and simplify. Okay, so again, like I said, sometimes we don't want to rationalize the denominator. Sometimes it's not very useful. Okay. All right, so what would I multiply by here to rationalize it? Yeah? Correct. In the numerator and the denominator. Okay. So when I do that, in the numerator, I'm going to get square root of x times the square root of x is x. And then 2 times negative 2 is minus 4. Okay, and I can already see here, oh, that's going to factor as well. The x squared minus 16. So I'm going to do that all in one step. Okay, the x squared minus 16 is also a difference of squares. So x plus 4 times x minus 4. And then I still have this conjugate, square root of x minus 2, left over. Okay, but then again, I get these factors that cancel. And what's left is in the numerator, I have 1 over x plus 4 times the square root of x minus 2. Okay? All right, questions with any of that? Okay, so I'm going to leave it there right now.